Welcome everyone to Ask Tom Live. Great to have you along. Welcome to 2026. I must admit, full disclosure, the energy levels are a little bit low. And yeah, basically it's your fault. I've had customers absolutely clamoring to get 26AI education and demos and stuff done of late. And so this week, Monday, Tuesday, Wednesday, each night I've had 3 webinars to give to customers, typically within the 2.5 hours to 4 hour range. And of course, because they're all over the world, they've all been after midnight. So it's fair to say I'm pretty much toast. So I apologize in advance. I'll do my best to keep the energy levels up, but I have to admit, there might be some yawning tonight. We'll see how we go. So it's been a hell of a week. So if you people could be just a little less excited about 26AI, that'd be great. But no, it's great to see. Yep, that's good. Someone's saying up the chat line, which means we can get on the chat, which is awesome. So we got a normal office hours. We got some demos and some slides to get through. Apologies in advance if I start to melt. It's been very, very hot. If you're a US person on the call, well over 100 today, 38 degrees Celsius. And I turn the air conditioner off so you don't get an annoying background hum on the audio. So yeah, I'll slowly get more and more precipitation, let's just say, or perspiration. But either way, let's get our screens going and let's get straight into the content. Let me adjust my screen so I can see what's going on. Hopefully you can still see me and you're good to go. And it says, give me a link to download. We'll get to that shortly. Getting in touch is easy. You can just scan the QR code or just head over to linktree/Connor. That'll get you my email, blog, Facebook, Instagram, LinkedIn, GitHub repo, etc. All the ways you can get in touch with me, even on the cesspool that is X. You can get me on DMs there, or Blue Sky, which I probably prefer. Is just a bit more of a civil place to have some discourse. If you're new to office hours, well, sorry, I should say, we don't call it office hours now, we call it Ask Tom Live. If you're new to the live sessions, welcome. Don't be concerned when you see all the content shifted over slightly. It's such that when we make this into a YouTube video, we can stick my ugly mug at the top right, and it doesn't cover up any of the important content for you. As always, I like to start with a few bits and pieces about what's happening out there in the world in terms of software, user groups, etc. Obviously, first of all, Happy New Year. We made it through 2025. Let's all hope we can make it to 2026. I'm not going to get political on you, but it's fair enough to say there's enough political problems going on in the world that hopefully they can all get resolved this year, and all those kind of things open up more opportunities for us to all to come together as communities wherever it is all over the world. So that's about as political as I'll get. But yeah, obviously the most important thing is Happy New Year. What's coming up for me in a few weeks' time? If you're in India, please come along to our All India Oracle User Group AI and Multi-Cloud event. This used to be just called the Multi-Cloud event, and SAI is now calling it the AI and Multi-Cloud event. That's not just to leap on the AI bandwagon. That's a nice reflection, I think, of the fact that multi-cloud is now, for lack of a better term, I would call a solved problem. We used to have dedicated multi-cloud events because there were all these interesting scenarios. You could use Oracle on this cloud, but maybe not on that cloud. You could use certain Amazon facilities against certain Oracle features, etc. So there's a lot of complexity there. But now, everyone seems to be playing nicely together in the same playground. So you can pretty much run an Oracle database on any cloud now, and it all just works pretty much as you'd expect. So multi-cloud is finished. So SAI has morphed this conference into the latest and greatest thing, which is obviously AI. Head over to AIUG MC 2026, and that'll be in February. Whilst I'm in India, it seemed remiss of me not to head into the AI World Tour. If you go to, or just search for, I'm sorry, I got the link there, haven't I? Yeah, you can see I'm tired. If you go to oracle.com/in/AI World Tour, that'll take you to the India leg, but there's a link there also to the main AI World Tour. We've got events all over the world for people that couldn't get to Las Vegas last year. I think there's already been some, maybe I think Dubai. There's a couple in the Middle East I think have already happened this year. Most of them start in February and March, but I'll be in the one in Mumbai, once again doing a little theatre presentation on some cool stuff in 26 AI. So if you're in Mumbai, please come along and say hello. I should say with the multi-cloud tour, we got, if you're interested in DBA work and upgrades, we got Daniel Overby Hansen coming along from the upgrade team. And if you're interested in tooling, we've got Jeff Smith, SQL developer, SQL CL coming as well to India. So yeah, that'll be some really good fun events for the user group. I'll be lucky enough to speak at Apex World in March. That's in the Netherlands. I'm very much looking forward to that. As I said, we're expecting a big release of Apex some stage this year, which will obviously have a lot of AI and Apex Lang features in it as well. So lots to talk about there at Apex World. And interestingly, I got asked to talk at a non-Oracle conference, one of the Vox Days ones in Zurich. So I'll be heading over to Zurich. One of the Oracle aces, Jasmine Thury, will be also speaking there. But yeah, if you're a developer and you're in Zurich, please come along and say hello. Pretty excited to talk about some cool stuff in the Oracle database to not necessarily an Oracle audience. All those things, as always, are all about me saying support your local user groups. While I'm in Netherlands for that talk, I'll also be popping down to Austria and Romania to do some talks for their user groups. So if you're on the call from Europe, if you're in Zurich or Netherlands or Romania or what the other side, Vienna in Austria, please reach out to your local user group contacts and hopefully we can catch up and talk tech, have a beer, etc. That'll be very cool. Now, just like I said last month, have I forgotten some particular announcement that might be of interest? Yes, hopefully you're all now well aware that after an extended period of time, 26AI will be released for on-premise databases for commodity hardware. So you don't have to run it just on cloud, you don't have to run it just on Exadata or engineered systems, and you can do something more than just running the free version. Hopefully you've all been playing with the free version to actually get yourself up to speed with some of the stuff in there. But if not, feel free to hit me up and we'll maybe do a talk on 26AI features on one of these Ask Tom live sessions. Or, as I've been doing this week, if you're a customer and you're an Oracle user, don't hesitate to reach out and we can do something in private for your particular customer. As much as they're draining on me and they don't really scale in that sense, I really enjoy doing them because people are generally much more open on those events, because if you're just amongst your own customers, you can say things about, what you're doing as a customer, what your goals are, what your strategies are, how Oracle works into all that, all the kind of things you generally wouldn't share on a public webinar like this one. But I digress. 26AI is coming on-prem very soon, so I'm very, very excited about that. So what's come in as some questions? We actually had a 26AI question. This one came from one of the customers on one of the webinars we did earlier this week, and I said I would get round to answering it. And I said, but I couldn't do it at the time, so I said, please come on our Ask Tom live session and we'll do it. So we'll talk about group by all. We'll talk about histograms at length, talk about connect by versus with, some new advice on virtual indexes. I did some content, a video on virtual indexes a while ago. That content is now somewhat obsolete because we've improved things, so I'll talk about that. Flashback transaction not working and multiple values in Scalar queries. I'm not sure they're actually in the slides in that particular order, but we'll do our best to get through it all. So let us start with group by all, and here's the question that came in. I saw the new group by all in 23AI, that's 26AI, as I say, we got to bring our customers up to date. It seems that the whole group by is redundant because we always have to group by everything that's not, count, min, max, effectively anything that's not an aggregation function. Isn't everything just group by all by definition? And that is a valid point. You think the moment a SQL parser saw the word an aggregation function in there, you could literally have your function, your columns, your aggregation function, your from clause, your where clause, and then by definition you have to have a group by because without it it wouldn't run. So why not just put it in automatically? Group by all is close to that, and I thought we'd explore some idiosyncrasies with group by and group by all. And just to cover quickly the cool things in 26AI. So to answer this person's question, I say yes and no, because as I said, there's a little bit of nuance involved. Let's bring it up. So this is just running the free version. We don't need anything special for this one. So what did I call it? I think that. So first of all, I'll show you a couple of cool things very, very briefly, because I'm sure you've probably seen these in some 26AI content I've done or other people have done before. A couple of very cool things in 26AI. One is The old days of having to cut and paste everything up here into your group by are a thing of the past. If you've got an alias now, you can now group by the alias. So that's a quick teaser there that one of the cool things is no longer having all those expressions you have in your group by clause, in your select clause, being replicated into your group by clause. So that's cool. But that doesn't help when you have queries with lots and lots of columns that aren't necessarily expressions. So for example, if I had something like this, select all these columns and then count star, well, all these things are effectively self-aliasing anyway. I don't get any benefit by referring to their alias because they're just column names anyway. So I still have to repeat all that stuff. And that is just as equally frustrating as having the group by being able to use expressions. So we wanted to tackle this as well. And so there's the result. Can we do it without all that verbose SQL? And as the topic of this question suggests, yes, we can. I can do select all these columns. There's my aggregation function. Obviously, I could have more than one aggregation function. And wait for it, drum roll, please. You can just do group by all. And it works. It went and got all the stuff that wasn't aggregated and did an implicit group by. So that's cool. As the question came in suggests, that would think, well, why shouldn't every group by just be this? Why wouldn't you just, as a IT standard now, always do group by all? Well, to answer that, I have to say, hold on there. Let me show you a couple of examples. Let's say, and this is a common thing you often see when people are doing things like in Application Express, etc., when they want to get back multiple pieces of information as a single string, we might do some simple concatenation. So in this case, I've said, go get the department number and the sum of the salary, but I want to bring it back as one attribute, so I'm simply concatenating it with a delimiter, go get that and group by department number. Makes sense. So in this case, I'm getting all the results I want, but I'm not getting it as two columns, just as one column, and maybe some downstream process will parse it out based on the colon, etc. Fictitious example. I look at it and I think, well, as I've said, I've come up with a new company standard, which is, why bother with this? Every group by is implicitly a group by all. So let's run a group by all and see what we get. We get an error. Isn't that interesting? You can't just smack in group by all anywhere you like. Now, to explain why, let's dig a little bit under the covers. So you're probably familiar with this utility. I've used it a few times in previous sessions, that you can use dbms utility expand SQL text, where you pass in the SQL text you're actually throwing at the Oracle optimizer and transformer, and it shows you actually what it presents to the optimizer after it's done query transformations, etc. And this is what it sent. It said, yes, to do this query with the group by all, I do select the expression you saw, give it an alias from, and there's no group by. It dropped it off. That seems almost like a bug, doesn't it? So let's go a little bit further with another example to see exactly what's going on. This time I'll do select department number, trunk of the salary plus sum of the salary, and because that's an expression, I have to do department number and trunk. Now I chose trunk here because trunk to 10,000 returns 0 for all rows from the employee table. So in effect, I'm getting the same result back that I would normally when I do a group by department number. So I didn't want to confuse things here. So this really evaluates to 0 all the time, but because it is a column that is not used in an aggregation, we have to group by all those elements. Same thing problem occurs here, right? If I try group by department number and trunk and replace it with group by all, I get the same error. But this time I've got two columns that I group by, followed by an aggregation. Let me expand that out. This one again. So this one I've got a column that needs to be grouped by, a column needs to be grouped by, and the aggregation. Let me expand this one out. And now I do get a group by, but only by department number. And that seems odd. It's not like the first example where it looked like we stripped the group by off altogether. This one actually kept the group by, but didn't keep all of the group by we needed. It needed the group by department number and trunk of sal. And this starts to get a bit of a hint as to what's going on. Let's go back to the slides. The SQL standard has supported group by all for many, many years. I think it appeared in maybe SQL 1999, like literally that far back. But the definition of group by all is not what perhaps we would assume as humans, which is anything which has an aggregation, just grab everything else. The definition of group by all is all columns not involved in aggregation. Now, if we jump back to our example, this expression is involved in an aggregation because we're doing addition with it. So group by all, by definition, says every column that is not involved in aggregation. That's not involved in aggregation. This one is involved in aggregation, even though it doesn't have an aggregation function around it, like sum, average, min, max, but it's involved. It's effectively, it's related to an aggregation here, and therefore that is not involved in group by all, and therefore we get the group by department number, and in this case we get an error. So be aware, group by all is not synonymous with what you might imagine it to be, which is just go hunting around for anything which is an aggregation, throw that away, and whatever's left is what I group by. We could have chosen to do that implementation, but we generally in Oracle, we like obeying the SQL standard. So that's what it is. So please don't just make a company-wide policy that you can group by all everywhere. There's a very good chance you can group by all in 95% of the chances code you have, but don't just do it, carte blanche, because you might start getting some interesting errors. Okay, histograms. Here's the question that came in. I'm struggling to understand with maybe what a hybrid histogram is. I assume this is something that's coming in 19C. Can you explain what it is and how it's different to the standard histograms we have? So I've got some bad news for the person that asked this question. Hybrid histograms did not come in 19C. They literally came back way back in Oracle 12C. However, there are many customers that have not yet seen these because they haven't got good statistics gathering scripts. We'll cover that shortly. For the rest of this little chunk of this question, I'm going to use this table as a baseline for our kind of stuff. So I've got an orders table here, and it's got a status column inside it. And we're assuming this is like similar to a typical kind of retail operation where people come place an order, and initially that order is new. And when the order gets placed in our system, when we're going to assign it to someone to deal with it so that it becomes assigned, and that person says, okay, yep, I'm now working on your order, so it becomes in progress. They'll eventually process that order. Once it's been processed, eventually it'll be shipped. Once it gets shipped, we'll get, when it gets delivered, the person will say, yes, I've received your order. At that point, we say the order has been completed. And then at some stage in future, all of those completed orders become archived. So there's your sort of typical natural workflow that comes in maybe some sort of retail system. And the numbers here are probably reasonably accurate. Lots of new orders coming in. We don't want many orders assigned because as quickly as possible, we want them to be in progress. And similarly, we don't want many orders to be processed because as soon as we process them, we want to be shipped and have them out the door. And ideally, lots of received, lots of completed, and lots of archives. So I picked some numbers here to populate this table that hopefully, sort of similarly reflect real life. Chat question. Oh, missing the group by all. Very touche, Alan, touche. Yes, this could have been grouped by all. I'm old school. I'm a dinosaur. Don't hassle me, Alan. I'm tired. Oh, someone jumped on the Q&A, which I haven't been looking. Someone said, is this a new enhancement of expand SQL text that it works with a statement that gives an error? Previously, it did not. It depends on the kind of error. Because it depends on where we actually tackle it. I think things like non-existing tables or things that are syntactical errors, like if you did select with the letter X attached to it, I think you get an error. So we've got syntactical errors and then semantic errors and so forth. So Judith, I think it depends whereabouts we would find the error. I don't think anything's changed. I think that's just depends on where the error sort of occurs. Hopefully that makes sense. What do I do? Answer live. That's done. And I would say I keep an eye on the chat more regularly in the Q&A, so maybe work on that. Now, that data is skewed. We don't have an even distribution of the data, so that would suggest we want to create a histogram. And in 11G, this might be the kind of thing we would do. We would do gather table stats for the orders table. Now, I know there's only 8 distinct values, so I've picked a nice value of, that's above 8, which means I should be able to get a frequency-based histogram. If I have more histogram buckets than I have distinct values, then the database can store good, accurate data for each of those distinct values, and it's called a frequency histogram. And it looks a bit like this. We have this thing called the endpoint number, and effectively a shortened representation, because this has to handle all data types, varchar, twos, dates, numbers, etc. But we can pretty much work out what's going on here. That effectively we have 1000, 1010, etc., etc. These numbers look cryptic, but if we take each endpoint number minus the previous one, something like this, we actually start to see how the frequencies are stored in the database. The difference between these two endpoints indicates the frequency for assigned. So we have 1000 values of never, of new, 20 values of assigned, 4000 values of in progress, 3 values of process, etc. The delta between the endpoint numbers indicates the frequency. That's what a frequency histogram does. Because we know, based on the stats, exactly how many occurrences of each different status there are, our optimizer is getting the best information it can. If I say, show me all the orders where the status equals shipped, well, the true value is 800, and our execution plan said, yep, I expect to get 800. That's perfect optimization. Obviously, as the data changes and the stats get out of date, that would drift a bit, but at the moment, as it currently stands, a frequency-based histogram is the best you can have because you know exactly what each static value has. So far, so good. That's fine until the number of distinct values goes above 254, because I'll just say in earlier versions of Oracle, and most versions of Oracle still today, the upper limit for the number of histogram buckets is 254. So if I've got 300 distinct values in a column, I can't obviously store the exact count of each occurrence in 254 buckets. Now, I put an asterisk there. We actually changed this, I think in either 11.2 or 12, we let you bump that up to 2000 if you want, but it's a preference you have to set using DBMS stats. If you don't, the upper limit is 254. The reason we did that is if you simply said, okay, everyone gets 2000 buckets now, then that's a lot of data dictionary information you're storing. So we'd say, use judiciously and wisely. But let's assume 254. Now I've only got 8 distinct values for the status, but I can mimic not having enough bucket by basically hobbling the optimizer. I say, when you go gather stats this time, you're only allowed 6 buckets. And remember, we're still on 11G here. On 11G, when the number of distinct values outweighs the number of buckets, we get what's called a height balance histogram. Once again, if I do my query here, I get a slightly different representation. And that is, the endpoint number is not now a frequency count, because it's no longer a frequency histogram. It's effectively a bucket representation. And once again, doing the delta, we have this thing of an end value of new has no buckets, 6 has 1 bucket, 7 has 2 buckets, and 8 has 3 buckets. It's probably easier to display that pictorially. There's my 6 buckets, and we can imagine these values sitting effectively between the buckets, which says 6 buckets, therefore 16%. We're basically saying 16% of the data has a status between 1 and 6. 16% of the data has a status between 6 and 7. Because these two are the same, we're basically saying 16% of the data is 7, 16% of the data is between 7 and 8, so probably 7 again, and effectively these 3 buckets are saying that effectively span the 8 archive. So the amount of buckets you span is an indication of how often that value occurs. 8 occurs across 3 buckets, so it's a big portion of the table. As we know, I think it was 25,000. 7 is the next largest, and everything else fits between 1 and 6 in this 16%. So when I do things like, for example, 8 of archived, remember the true value was, I think, 20,000, it might have been 25,000 actually. I think I got that number wrong. I think the true value was 25,000. Oh no, I'm wrong. It was 20,000. Sorry. True value was 20,000. The optimizer was pretty good. For those big values that dominate lots of buckets, the optimizer actually was pretty close. When I went for 7, which was a little bit larger, okay, the true value was 10,000, and the optimizer this time was out by a factor of 50%. That's not so good. And generally, these are the kind of problems people started having when they had height balance histograms. It became a bit of a coin toss as to whether your estimates would be good or bad. So where are those numbers coming from? Well, the database knows I had 45,000 rows in total in that table, and we've got 6 buckets. So the database, I'm keeping the maths very simple here, loosely about 7,000 rows per bucket. A little bit more, 7,500 to get to 45,000, but let's keep it loosely at 7,000 to keep the maths simple. Because 8 spans 3 buckets, it says, oh yeah, so 8 is probably 3 times 7,000 rows, about 20,000 rows. That's why it got lucky with the value of archived of 8. It just so happened that the multiple of buckets roughly equated to the actual value of number of rows for archived. When I went to 7, I got a bad result. It guessed 15,000. That's because all it knows is that 7 is involved in 2 buckets. So it said, okay, 7,000 per bucket, double that, I expect about 15,000 rows. In reality, 7 occupied 1 bucket and, for lack of a better term, half a bucket. There were 10,000 rows for the value of 7. It filled a bucket, it just bled over into this one, and so we assumed a whole bucket, but in reality, it only used half a bucket, but the concept of half a bucket doesn't exist in the histogram. So that's why it was wrong for 7. And similarly, once we get into those values that all fall into one bucket and we don't have any extra granular information, things get a little bit all over the place. So in this case, the value of 2 assigned, which was all sitting between here, all in one bucket, we were actually miles off. Effectively, we had about 5 distinct values. So we did 7,000 divided by 5, got about 1,200. That's what we expected. In reality, there was only 3. This would be a genuine performance threat, because if we only have 3, we're probably looking at scanning that and maybe using a nested loop. If we expect 1,200, we might jump to doing a hash join or something less efficient. So these are the dramas with height balanced histograms. Basically, when values span buckets, like our value of a status of 7, we might have dramas, and what I call bucket swallowing. Lots of different values all falling into one bucket, 1, 2, 3, 4, 5, and 6. We can have dramas as well. That's all you get in 11G. And that's literally the only 2 you had. And obviously there were significant problems with height balanced histograms. One footnote, and this applies to 11G and all versions onwards. As you can see, once you get into not enough buckets, right, you start having problems, but you get height balanced histograms. So you may as well choose all the buckets you can. Just if you have only 8 distinct values, doing size 254 won't create 254 buckets. It'll only create 8 distinct buckets. So you may as well do that. And that's what auto does. Choose the largest number of buckets available to you, and then effectively you'll get a perfect frequency histogram if possible. Otherwise, you'll get probably the best height balanced histogram you can get, but obviously they still have some shortcomings. So moving on to 12C, we can repeat those same demos. I've only got 8 distinct values. If I give more the buckets than I have distinct values, I get a frequency histogram because that's perfect. Let's now repeat it with 6, which gave us a height balanced histogram before. Now we get this new one called a top frequency histogram. Now, that's not a frequency histogram, it's close, it's our best guess. We couldn't do frequency because we didn't have enough buckets, but as we were looking at the data, we saw enough of the information to say, I can make something that doesn't have to fall back to a height balanced histogram. If we look at our data, once again using our simple query against the histograms, we see what information we get. We're actually getting the accurate frequency information, but not for all the values. So the value for 1 is 1,000, correct? For 3 it was 4,000, etc. 8 it was 20,000. So these frequency values are all correct. So when I do a query on any of these known values, did I put it in here? I didn't. When I do a query for any of these known values, I'm going to get perfect estimates because it's effectively the correct frequency of each of these values. So for 6 out of the 8 values, I'm golden, even though I didn't have enough buckets. I've got obviously 2 values left. Value 2 and value 4, I don't have information about. So this is what I've got, right? Buckets for exactly these frequencies, so I'm going to be perfect for them. What about the others? Well, the others we can work out heuristically, and we can get pretty close. What I've got is 45,813 rows in the table. That top frequency histogram collected 6 rows of correct frequencies. So these are the 6 values here. So the database knows that I've got 45,800 rows in total. It knows that I can account for 45,800 of them with these 6 distinct values. I know there's 8 distinct values in total. So now we can do some maths. I've got this many rows in total. I've accounted for this many of them across the 6 most popular values. Therefore, I've got 2 values unknown and only 13 rows left. So on average, it's 13 divided by 2. I would expect those two remaining rows, value 2, status of 2 and status of 4, to only have 7 rows between them. And as we see, that's where we get this estimate of 7 from when I look for 4. The true value was 3, but it made a pretty good guess. So a top frequency histogram is as close to a frequency histogram as we can get without having sufficient buckets. Now the question is, what defines whether I can do that? I had 6 values, 6 buckets, and I had 8 distinct values. If I had 500 distinct values, maybe it's not good enough just to have frequency data for only 6 of them. So what's the formula? We decide that we can do a top frequency histogram if the percentage of the top occurring values is greater than the buckets minus 1 divided by total buckets times the number of rows. That looks a bit cryptic. Let's look at a real example. Let's say I had 1,000 rows in my table and I'm allowing 12 buckets. If the 12 most frequent occurring values sum up to 11 divided by 12 times the number of rows, which is 920 rows. So if the 12 most frequently occurring values sum up to 920 of the 1,000 rows, then that's good enough for me to use a top frequency histogram. I'm happy with the fact that I can cover at least 920 out of the 1,000 rows with my 12 buckets. If I exceed that count, then I'm going to use a top frequency histogram. If I don't get that, it means I've got too many distinct values for the number of buckets I got, so I have to do something else. So what if top frequency is not possible? Well, to do that, I'm going to have to pump up some more data into my table. I'm not going to change the distinct values, but I'm just adding more data for each of the existing statuses, which gives me a total of this. This will bring me back underneath the threshold for using a top frequency. There's not enough of these values stand out as opposed to the others to use a top frequency histogram. So now when I gather size 6, I couldn't do frequency because I got 8 distinct values. I couldn't do top frequency because the values were too spread. So I end up with this thing called a hybrid histogram. If I look at this, we have some frequency information as before, our same bucket distribution, but we have an extra column called the endpoint repeat count. This is where the hybrid element comes in. So let me draw some buckets again. So what I've got is those values: new, in progress, shipped, received, completed, and archived. These are the buckets. So I don't have anything spanning buckets anymore. I don't have 8 appearing multiple times like in our height balance histogram. Each bucket only has a single value associated with it. And we also have this extra number, the endpoint repeat count. And that is, if I go back to the frequency and look at just this last one, what's a better one? Maybe this one, number 5. Number 5 says, I've got 1,125 values in this bucket, and the upper limit for this bucket is the value of status value of 5. And what the 535 means is that 535 of the 1,125 are the end value. So if I type in 5, oh no, that's right. So unfortunately I didn't copy this 1125 over. So if looking at this bucket has 1,125 values represented by it. It contains, by definition, the values 4. The database doesn't know this, but the 4 and 5. But we know that 535 of the 1,100-ish are the value of 5, and therefore we can use that to effectively fill in the blanks for missing values. So if I dig into this particular one, 3 in progress, I know that the sample size I used for my estimate was 5,450. I didn't actually read all the rows. I know the total number of rows is 93,000. So when I'm doing estimates, I say for the value of 3, in progress has 586 occurrences out of a sample size of 5,450. So about that percentage of the total number of rows is the number of rows that have the value of 3. And if I do an execution plan, I was out by 1. But that's when you have known endpoint values. When the value you're looking for is the value for a bucket, then I'm going to get exceptionally good results. If I'm looking for the values that are not in buckets, well, I'm back into a similar kind of scenario. And that is the sample size is 5,450. The known endpoint is 4,306. Where did I get that from? Oh, sorry, yes. If I sum up all the known endpoint values, sum up this column here, there's 4,306, which means the delta between those two, right, is 11,100. 1144. So that divided by the sample size is the percentage of unaccounted for rows. And that's across the number of total distinct values, number of rows I got here, which gives me roughly about 10,000 rows. And that's the estimate I'll use for this value here, right? It's not as perfect as a top frequency or frequency, but it's a lot better than a height balanced histogram. Okay, hope that it helped. The benefit of this, as we saw from our diagram, I went back too far, there's no bucket spanning. These values here don't span buckets anymore. You have to go forward a long way. There's no bucket spanning. And a key point is you only get hybrid histograms if you're using the auto sample size. And I think that's what led to this initial question. If you've got your own stats collecting scripts and you've been using that classic thing of, I want to make it nice and fast, I'm going to use estimate %5, estimate %10, etc. Even estimate %100, any estimate % that is not the auto sample size will not build hybrid histograms. It will build height balanced histograms, and so they'll be lingering on in your existing systems, even though they're the worst kind of histogram to have. Now, you still need care. Man, I'm laboring on this one. Even though you've now got frequency and top frequency and hybrid, all super cool pieces of optimizer technology, they only make sense is if those stats reflect reality. Here's an example, a really common one. Let's say you've got some day of the year that you're a retailer. This is a retail example with my orders table, where you go nuts. You give everyone these amazing deals. It's the biggest day of the year for you. You've got to make sure your performance is absolutely bang on this particular Black Friday, Cyber Monday, whatever day it is you choose. Now, you're going to have, obviously, on your website, just like Amazon did, just like eBay, Walmart, all those places, they say, okay, because it's Black Friday or because it's whatever, we've got some super special hot deals. These are the things that people are going to be going for. Now, when do we normally gather statistics on our databases? In an off-peak time. So here, let's say at 3 a.m., I go gather stats. Now, at the time I gathered stats, the number of things I'm letting people buy that are for sale, because Good Friday hasn't started yet, is 0. So the database doesn't know about our hot deals. And then at 5 a.m., you've probably promoted this on social media, log on at 6 a.m. or 5 a.m., and we're going to update certain deals and say, yes, you can now buy a fridge or a TV or whatever. So you've picked 14 items that you're going to give these amazing specials to get that excitement. It's like those after Christmas sales where they they open the doors and everyone pours in and they sprint to the nearest doorbuster deals. So now I've got 14 hot deals. And then for your busiest day of the year, what is every query going to do? It's going to have that as a predicate, because that's what everyone's looking for. Show me the hot deals. Show me the hot deals. That's the one most important query you have to optimize correctly. And what happens? Your Exadata machine catches on fire. Why? Because when you gathered stats, there were no hot deals. The database has no idea how to optimize this, because this is not what the optimizer looks like. If I go look at the database, you don't get this row. If there's no hot deals when we gathered stats, that row doesn't exist. This is the only information inside your frequency histogram. We can't invent data for data that isn't known yet. Now, normally, the optimizer's calculation for example, top frequency kind of stuff is I've got 1 million rows, 7 distinct values. I've got a frequency histogram. There's 4 popular values. That's these 4 here. That adds up to 910,000 rows. There's 3 values left to cover the rest. That's 3 divided by 90,000. That gives me a density formula and tells me how the density can be used to work out my estimates. This is the town in mathematics the optimizer is doing. It's saying I've got 3 values spread over 90,000 rows. That's going to give me basically 30,000 rows per unpopular value, of which hot deals is 1. But if I go now digging into the 10053 trace, well, someone says, show me the hot deals. Well, when we calculated the optimizer stats, there were no hot deals. So the number of values in your table is 1,067,091. The number of popular values is all of them. It's those 4 values we had that weren't hot deals. So it's all of them. So now I'm doing a calculation, which is number of distinct values divided by something minus itself. Dividing by 0 is not a popular pastime for anything involved in mathematics. And your optimizer goes, I don't know what to do. So what does it do? It decides there was 2000. Where on earth did 2000 came from? Well, the database said, this is a value I know nothing about. I'm guessing it's rare in some way, shape, or form. So what did it do? It said, let's pick the lowest thing I know about, archived, and halve it. And we get 2107. That's roughly what it did. That's the best. I think that's a reasonable assumption. It said, well, this is rare. I don't know about it. So pick something I do know about, and let's assume it's half of that. It's just burnt into the algorithm. So what was critical was that you gathered stats when you had some hot deals, because it doesn't matter how good your stats are. If they don't represent the reality of your usage, then you're in trouble. Get your representative values at the right time. So just to quickly sum up, frequency histograms, absolute bangers. Make sure you're using gather auto, because that'll be the largest number of buckets available to you for all columns auto. So yeah, make sure you're using for all columns auto. If you can't get a frequency, you'll get a top frequency. If you can't get a top frequency, you'll get a hybrid. If you are seeing height balanced histograms in your database, it means either you've upgraded and you've never regathered stats on those objects, so they've been hangovers from Oracle 11, or you're not using sample size auto, you're using an estimate percent, and therefore you should change your scripts, because you don't want any of these left over, because you'll generally get worse plans. Whew. Someone's back in the Q&A again. Does the database use SQL execution statistics to update the optimizer stats? That is a big question. That very much depends on the version of the database you're using. It depends on the platform you're running. It depends if you're cloud or on-premise, and also depends what parameters you have set. So maybe I'll take that one offline and do it in maybe next month's office hours, because I'd love to give yes or no, but there is a plethora of scenarios that we would need to cover. So yeah, I need to, we'll have to, let me cut and paste that one, store it somewhere. Bear with me for a second. You'll see my text pad come up. Let me paste that somewhere in case I lose the chat, and we'll tackle that again at a later date. How are we going? Oh man, I went too long on that one, didn't I? Scalar queries. Here's the question that came in. It seems to be a common practice at our shop for developers to use scalar queries instead of joins. One thing that particularly frustrates me is repeated queries to the same table. Can I at least give my team some improvements in that area? So I could just rant and pontificate about, you know, your developer should understand what a join is. That's the underpinnings of relational theory, but I don't want to be negative on the call. So let's just do, let's basically talk about how we can maybe make things a little bit better. So these are the kind of things that tend to create these scenarios. I've got a customers table here. I've got some customer data, and for each customer, we've got some ID values, which typically means these are foreign keys to parent tables. So I've got a gender ID, a country ID, and a company ID, and often we have lots of these things. You know, good data modeling if we have, you know, foreign key lookup tables, etc. If I go look at these kind of tables, you know, I've got a gender table, ID 1 is male, 3 male, none, etc. Country is Australia, USA, Japan. I've made these simples, you know, these examples very, very small. When people need to obviously populate this data, oops, press the wrong key, this data for their applications on screens, obviously users don't want to see these primary key surrogate keys. So these are the kind of things we see. It should be a join because that's what the data model is designed to do, but often people build it like this. And I don't want to cast aspersions on developers doing this. It's a common mindset because you say the module specification you're given says, start with the customers table. And so you write a select from the customers table. And then it says, for the gender ID, find it from the gender table. For the country ID, find it from the country table. And a novice developer will often say, oh, well, I go do a lookup. At least here they're doing it in the SQL statement. a lot of applications out there do a select from the customers table, and then the application tier comes back and actually runs individual queries to get the bits and pieces. So at least here they're doing it at least all on the database. These are called scalar queries, queries that you run on the select phase of your clause. So it should have been a join, but we are where we are. A join is generally going to be a better option, but this is what people do. The main problem is sometimes the information you want to get using a scalar query is not just one value. The previous query just got the company name, but maybe I want the address and the revenue, etc. And this is the thing that frustrates the person that asked this question. These kind of things, where I'm going and getting multiple columns from the same table, from the same ID, etc. I'm literally visiting the table multiple times because, let's face it, the moment you see one scalar query, the mindset of a developer when you come to enhance this code is I'll just keep on adding. It's very hard to say I should redo this as a join, even though we probably should. And there are issues with this. These three things, the database in its current form is not smart enough to go, you're doing something potentially silly, I'll go consolidate them into one query. You can see we actually access the company table 3 times. Now, across rows, the database does some caching of scalar queries. We won't get into that too heavily tonight. So there are some efficiencies the database tries to do. But when you've got 3 queries, rest assured it's going to run those queries 3 times. And that's obviously not great. So as I said, the resolution for this really is just use a join. But if you don't want to, fight that battle today, you may want to leave that battle for another time. Maybe the next time you do a major refactor of your application. Is there a way we can get multiple attributes without having to do multiple queries? Yes, there is. We have to take advantage of some of the object relational features in the Oracle database. So I'm going to create a type here. It's called my company attributes, and it's the 3 things I want to get: the company name, the company address, and the revenue as an object type. So now I can go to one query, get all the attributes I require, and come back just as this. Now, the reason this works is a scalar query must return a single value. I can't do select company address and thing all on one scalar query. I'd get an error. But because I'm consolidating them into an object type, then I'm still returning just one value. And the data comes back like this. Now, naturally, the vast majority of applications out there are not going to understand what an Oracle object type is. Our own Oracle products will, but if you're running something in C# or whatever, it's not really going to understand this in simple form. So what do? Well, we simply do an inline view. I call this column, call it an attrib, and then I can simply do attrib.value, attrib.address, attrib.revenue. I put this in there deliberately. This fails. One of the rules with object relational tables is everything that's dragged out of an object must be aliased. So in this case, a simple inline view is not sufficient. I have to give that inline view an alias and then use the alias as a prefix to get those object attributes. But as you can see there, I'm now doing a single access to the company table and picking up multiple attributes as we go, and the problem is solved. And if we have a look at the execution plan, we can see we only visited the company table once. So we'll get some performance benefits as well. And at least one would hope that your existing development teams, if they see this, are going to have a reasonable understanding of what's going on. It's not too much of a departure, going full on into maybe using joins. So hopefully that helps. Someone said, is lateral join more appropriate for this sample? I would certainly consider a lateral join. I've literally just published a video today saying why I love lateral joins, because it creates it helps map what I call the human mental model of tackling a task in a step-by-step operation. Get the customers first, then get the company details, then get the gender details, etc. A lateral join leans itself naturally to that kind of mental model. So yeah, a lateral join would be fine. When I said just use a join, I wasn't excluding lateral joins. Check the video I put out, I think today, saying, I'm big fan of lateral joins, one of my favorite joins. Okay, virtual indexes, Redux. I put a video out some time ago to answer the question. Someone said, I need to know whether putting an index on will actually help without putting the index on, because that's an incredibly expensive exercise. And if it turns out it didn't help, then I've wasted a lot of the DBA's time and the server's resources. So this is the video I put out, Virtual Indexes, your DBA indexing insurance policy. That information in there, it still works, but there are better options and more supported options that you can now do. So let's do a demo of that. So just briefly, this is, in rapid fire time, this is the advice I gave you before, because this was pretty much your only option. I've got a table here. It's a copy of DBA objects, and there's no indexes on this table. And I've said select star from T where the owner equals some value, and as you'd expect, it's table access full. I want to know if an index on the owner column will help without doing the index. And this is the original advice I gave you. This is actually what Enterprise Manager used to do. Enterprise Manager used to have an option for, will an index be good? This is how it did it. It was undocumented. You could create an index with no segment. So the index exists in the definition in the dictionary, but it actually isn't built as an index structure. So it's instantaneous, no matter how big the table is, because it's not really an index. You would then set a hidden parameter, use no segment indexes equals true. And that says the optimizer is now allowed to use this index for consideration. Now, obviously you can't use the index for real at runtime because it doesn't really exist. But in terms of seeing an execution plan, you can do hypotheticals. You can say, if this index was actually present and I was to run this query, what would have happened? Because I'm just doing execution plans here, not actually running it. And it says, yes, I would have used the index. So this is that confidence you would have as a DBA to say, yep, it's probably worthwhile going ahead and actually building the index, because nothing would be more embarrassing if you went and built the index and then this was a full table scan anyway. So that's the advice I gave previously. Let me turn that set facility off now, because as you can see, it's an underscore parameter and you'd have to go speak to support to get approval for use, etc. There's a better way that doesn't need any of this undocumented stuff. Let me drop that index. Now we can create the index as unusable, which is obviously fully supported. Unusable indexes primarily were designed for example, loading data in and then building the index afterwards. So typical data warehousing workflow is create the index unusable or alter an existing one unusable, load your data, and then rebuild the index to get those performance loading benefits. So that was originally what this was for. They're also used for partial indexes, but we're going to use it in a new way now as a way of seeing whether an index would be worthwhile. So in the same way that a no segment index is instantaneous, an unusable one is the same, because we haven't actually built the index. Now, if I do, here's where it seems a bit confusing, because if I say set my session to only doing execution plans, there's my query, it doesn't use the index. The execution plan doesn't know about this index, and therefore I haven't really gained any benefit here. I was hoping to see index range scan, even though the index was unusable, but it didn't. Maybe I need to set skip unusable indexes equals false to tell the database that yes, you're allowed to now consider unusable indexes. However, when I try to do that, it's almost too strong. It says, nope, I'm not going to let you optimize this query because that index is unusable. I wanted to use it, even though this is just trace only explain. It says, sorry, you don't get to use it. So that's a problem. So we haven't really got any benefit here. And this is how it always used to be up until not too long ago. However, interestingly enough, rather than doing set auto trace explain, which actually just does a standard parse of the query and then looks at the plan, an explain plan is treated differently. I can say, if I explicitly say I want to do an execution plan for my query, and that index is unusable, it says, yep, I would have used the index. So this is slightly different than actually doing set auto trace only explain, because that's actually doing a parse. This is actually doing a parse under the veil of just getting an explain plan. So once again, as a DBA, this would give me the confidence to say, yep, it's probably worthwhile going ahead and building this index. Similarly, in a real life situation, I would probably want to create that index as both invisible and unusable. Therefore, no one can see the index at all, doesn't even see of existence. And as a result, I would also need to set this one to true and then do the same thing. Do my explain plan, see if the index would have been used, If I'm so, then I'm good to go. I'll then build the index, it's still invisible, and then make the index visible at an appropriate time when I can maybe monitor the system just in case there's any regressions. So yeah, so don't have to use no segment anymore. Don't have to use those special underscore parameters. Just have to use explain plan as opposed to set auto trace. Okay. The user said, how does the optimizer decide about using the index or not, or without any statistics? By default, it'll probably use dynamic sampling or the table statistics because it'll have the column statistics and it'll apply them to the index columns. The other option, if you want, you can call dbms stats generate. Is it generate? Yeah, generate table stats, which will use the table level stats to synthesize some stats for that invisible, unusable index. Okay, it's 9:57. This also goes for some time. We might defer this until next month. So, thank you for your time. Apologies for the low energy presenter today. But yeah, I'm just very much looking forward to a nice long sleep tonight and tomorrow. But as I said, first one of the year. Great to see you all active and about. 2026 is going to be an absolutely bumper year for the Oracle database because we'll all get a chance to finally go playing with 26 AI. Just to give you an idea, I now have my little demo deck now has about 90 demos in it, and I promised these customers I would do all the demos on their talks. And even on the 4-hour webinar that I ran 2 nights ago, we got through less than half. There is just that much amazing stuff in 26 AI. Blows my mind. So I am super pumped for when it comes along for everyone to use. It literally is a game-changing database release. On that note, as always, thank you for your time. It's been an absolute pleasure to have you here. And as I said, if you're in India next month, please come say hello. Otherwise, I'll see you next month on Office Hours. Bye for now, everybody.